Hi, mathematicians. It is time to do part 3 of our linear function pattern recognition, filling in the blanks. Our objective remains the same. We are finding missing values in tables or extending a table in either direction by using what we know about rates of change for linear relationships. Continue with our whole class practice. For each table below, fill in the blanks, identify the rate of change, the unit rate, and the type of function represented. So in this first table, as with any table, we are going to start by doing the change in x and change in y. So please do that now. You are labeling the changes for what you see. You can see that our change in y and our change in x are uniform, they're the same, which means the ratio of change in y to change in x, or our rate of change, is constant. It's going to be the same. And if our rate of change is constant, we know that our function is a linear function. And our change in y is -1, our change in x is 2. And remember, for our unit rate, we simply have to divide -1 divided by 2. That's going to give us -0.5 or -0.5. And that's what's going to be over 1. So as the x changes by 2, the y, as the x increases by 2, the y decreases by 1. As the x increases by 1, the y is going to decrease by 1/2. And I usually write that as a decimal, just because I think it's confusing to have a fraction within a fraction. Using this information, we can figure out our blanks. So we had 2 spaces, that is +2, for our change in x, but we need to split that in half because we have now 2 rows that make up that +2. So that's why it's +1 and +1. So -1 + 1 is 0. 0 + 1 is 1. So you can see that our x values are just going to go up by 1. So take a minute to fill those in. So you can see the remainder of your x values going up by 1. We're looking at our y values, and you can see 2 rows changed by decreasing by 1. We need to see what each of those rows between there. So what 2 parts make up -1? That's going to be -1/2 for each of those. So we're decreasing by 1/2, and you can write that as a decimal or as a fraction, which means 7.5 minus 1/2 is going to give us 7. 7 minus 1/2 gives me 6.5. Fill in the rest of the table. And there are the rest of the values for the table for number 4. We're going to do the same thing for number 5, where we are looking at change in x and change in y before filling in those tables. Take a moment to do that now. So looking at our change in y, we see that we are going by 1 and then we are going by 2 in terms of the rows that we're talking about. And so we have a decrease of 64 and a decrease of 128. Those two numbers are related to each other. 64 times 2 is 128, so you can recognize that there is a proportional relationship there. Same with the change in x. We have a change of 8 and a change of 16 when we jump 2 rows. Again, always remember you can refer back to the number line, -6 to 2. You go -6, you go 6 units to 0, and then 2 more to 2, that makes 8. And when you're at 45, yes, that's off the graph after the number chart, but you can recognize that you would be going to the left, and it's 45 spaces till you get to 0, and then you're going to go an additional 19 to get to -19, and that makes that -64, or decreasing by 64 there, just like this one was increasing by 8. That's where those values come from. And hopefully you see that this is a constant rate of change. We can confirm that by looking to see if our two ratios are equivalent. Are they equivalent? And we have negative 64 over 8, and we have negative 128 over 16. If we divide those, we are going to get them both to reduce to the same unit rate of negative 8 over 1. And since they are constant, we know we have a linear function. Now we need to fill in our table, and we already know what one change is going to be. We know that from one row to the next, like we have right here, is increasing by 8. So that should be the same down our table. So take a moment to do that. Additionally, here we know that one row for the x's decreases by 64. So from that negative 19, you're going to decrease by 64. Let's fill in those values. And a quick double check to make sure that your table of values matches mine. Now let's take a look at the next problem, last problem, number 6. And again, we're always going to start with the change in y and the change in x. So please fill that in for the values that are given. That is enough. 3 points is enough to see if we have a linear function and if we have a constant rate of change. Hopefully you see the change here, negative 4 to 0. You can look at it on here on your number line, and then 0 to 6 is 6, both increasing going to the right. From negative 4 to negative 2, you are going also to the right, just 2 units, so it's positive 2. And then from negative 2 to positive 1 is 3 units. And you want to write your rate of change. You might recognize that 3 over 6 and 2 over 4 are equivalent to 1/2, so that those are equivalent, so that we know that this is then a constant rate of change because those fractions are the same. Or you can divide them on your calculator to be sure. But you have 2 over 4 and 3 over 6. These don't make a nice unit rate. It doesn't make a nice, we're going to have a fractional, a decimal in our fraction. And 2 divided by 4 or 3 divided by 6 both come out to be 1/2. And I'm going to write that as 0.5 in my fraction. That's my unit rate. So if my x is increasing by 1, my y is going to increase by 1/2. And of course, since it's constant, it's linear. Let's fill in the blanks. And our unit rate isn't going to be what we're looking for because our x's aren't going by 1s. Every 2 boxes here, 2 rows, is going by 4, but we're only 1 then has to increase by 2 because 2 plus 2 is 4. So we're going by 2s. And so we need to think about if x increases by 2, what is our y going to increase by? And to make that equivalent fraction, you can just extend your fractions there and say, okay, if x is increasing by 2, that means my y has to increase by 1. You can also see that in the table. 2 rows, the change in 2 rows is 2. Each individual row is changing by 1. So you can either think of it as an equivalent fraction or break apart that puzzle that's up here. So negative 4 plus 1 is negative 3, plus 1 is negative 2, plus 1 is negative 1, 0, 1, 2, 3. To fill in your tables, you're going to do the same thing for the x's, except for you're going by 2. And double check your work that it matches my table. Quick summary here. These 4 problems should look like the ones on your paper. You may have a few more details. You should not have less details than I have in my notes. I summarized, I always write down rate of change. It's something that we are going to continue to use throughout the entire year, that is the change in y over the change in x, and that your unit rate is something over 1. And you can divide out that change in y over change of x. Sometimes it becomes a decimal because it doesn't go in evenly, and that would be what you have over 1. And we've been talking about this every day. Linear functions must have a constant rate of change, which means that it has the same unit rate for any of the ratios that you calculate on your table. And then today we focused on finding missing values in our table. And I think of them like a puzzle. So if you know one part of the puzzle and you need to find out the individual pieces, you are breaking those apart. There's multiple ways to figure it out, and you can use what works best for you. All of us are in some way using the idea of rate of change and unit rate.